Hello and welcome to the Nex-G blockchain system demo. I will be your guide for this technology and take you through one of the many projects our blockchain team is currently working on. But what is blockchain? Blockchain is a shared and immutable ledger that gives us a way to track transactions. The most popular examples are Ethereum and Bitcoin. Since blockchains are shared and immutable, they provide transparency and security. Although this project deals with electric vehicle charging, blockchain has tremendous applications in banking, finance, food, healthcare, real estate, supply chain, and automotive industries, just to name a few. In the following example, we are answering the question, how can we connect electric vehicles to those who want to sell electricity? To solve this, we use the following technologies. Ethereum blockchain, specifically smart contracts, which are programs that run on the blockchain and are written in Solidity. The Remix IDE, which was used for initial development of the smart contract. Solx compiler, Web3.py, Ganache, which is a program that creates a local blockchain on our PC, and Rinkeby test network, which was used to test how the system would work on a real blockchain network. Now, let me take a minute to explain how this specific system works. There are three main players: the utility company, or grid, the electric vehicles, who will be referred to as EVs, and the charging stations, who will be referred to as CSs. Our system starts with a charging request from an EV with a specific price and amount of electricity it wants to charge. He sends this request to the smart contract, and the smart contract returns to the EV an auction ID, and also sends out an event letting nearby CSs know that there's a new auction open. The CSs, upon getting notified about this new auction being opened, send their sealed bid, which is a hashed version of their price and is stored in the smart contract. They, in turn, get a bid ID. Once the auction closes, the CSs now reveal their bids, and the smart contract selects the winner, which is the lowest price seller. The utility then takes the EV buyer price and the lowest CS seller price and uses their mean as a final auction price. Then it updates the balances of the buyer and seller respectively. If the auction happens to fail, the EV is notified and told to send another charging request. Now, let me demonstrate how our system works on a Ganache blockchain network. As you can see, I have already sent in a transaction to deploy our smart contract onto Ganache. Essentially, our first account will be used as utility, and the rest will be used as either EVs or CSs. Let us first start the scripts for the utility function and the script for the CSs. The utility function, which is on the right, is registering all the users on our Ganache and also adding an initial balance of 100,000. This is so that they can participate in the auctions. Now both the CSs and the utility are ready. Let us start by sending a request by an EV. As you can see, a new request from an EV was sent with auction ID 0 and a price of 41. Upon seeing these, the CSs sent their bids of 33, 5, 29, 14, 5, and 13. And they're now waiting for the auction to close. On the Ganache network, multiple EVs are sending their requests one at a time. Now, once the auction closes, the CSs will be notified and will start revealing their offers. Once all the offers are revealed, the buyer meter report and the seller meter report will be sent, and a contract state of 4, meaning it is ready for payment, will be set. Now, upon seeing this event, the utility now updates the balances of the buyer and the seller. I have made 3 containers, mainly for the utility, the CS, and the EV. The containers for the utility and CS are currently running, and they're ready to receive a new request from an EV. So let's start doing that. As you can see, the EV has connected to the Rinkeby test network and is currently calculating the gas price. Okay, so there was a new request from an EV from the address 25 BC with the buyer price of 20, and the smart contract returned its auction ID as 143. Above, the CSs sent their bids of 5, 31, 9, 37, and 10. And the bid was successfully sent, so a message was sent. And now they are waiting for the auction to close. Okay, the EV has now closed its auction, and the CSs are now revealing their prices. So, looking at these prices, 9 was sent first, and then at the end 5. So we should see a 5 for a seller price, and a message confirmation for a successful reveal was sent. The EV now has ended its reveal and is sending out an event so that the double auction can start. Now on the right, the utility has captured this event and is now sending the buyer meter report and the seller meter report, and will proceed on to updating the balance. It sends out a success message that the meter reports were successfully sent, and now it is updating the buyer and seller balances. As you can see, each transaction takes a little bit of time because every block is mined in about 15 seconds on the Rinkeby test network. So there is a little bit of latency on that. As we conclude this presentation, I would like to touch upon some of the challenges Ethereum is facing and how they are solved with Ethereum 2.0 and Web3. Currently, Ethereum transactions are slow and costly in terms of gas prices. Ethereum 2.0 will improve Ethereum scalability, speed, and efficiency. It deals with current bottlenecks in the Ethereum network. To be caught up with the shifting paradigm of blockchain networks, keep in touch with us at Nex-G. You can contact us with the information on the screen. I hope you had a great day, and thank you for watching.